today's our last lesson for Unit 9, and we're going to learn how to graph some logarithms. So let's go ahead and begin here. So I think I'll just go ahead and start by just giving you guys some steps that I'm going to use to graph logarithms. All right. The first thing you want to do is you want to find your domain. That's the thing where you set your argument greater than 0 and solve for x. We did that a little while ago. The reason we need to do that is because it tells us what values of x exist on this function. So knowing what values of x exist tells us what values of x we're allowed to actually plug in to get some points. Okay, so that's going to move us on to the second step, which is we're just going to plug in some points. Hello. Okay, so plug in some values of x that are actually in that domain and then solve for y. So you've got some points. We'll probably really only need about 2 points. You might want to make sure that they're spaced out though. So like usually like when we plug in points, right, like if I give you guys an equation and say, well, let's plug in some numbers, like, okay, let's plug in 0, let's plug in 1, let's plug in 2. The problem with logarithms is that they grow very, very slowly. Oh, there you go. I'm not too sure if this was already like this, but I have a Chromebook here with a V key that's on. I don't think it's going to go back on. Thanks, guys. All right. So what was I saying? Oh, yeah. So log functions, they grow really slowly. So if you plug in 1 and then you plug in 2, the y value is going to change such a small amount that it's going to almost look like it's a flat line. So don't do that. Plug in an x value and then pick another x value that's kind of far away from it. That way you kind of see the little bit of growth that it achieved over that distance. And by the way, that's why a lot of scientists and mathematicians enjoy log functions, because since they grow so small, they can be used to model things that grow too fast. So like the difference, for example, between a 6.0 earthquake and a 7.0 earthquake is actually huge. The amount of energy between those is so big. But by using logarithms, they can scale it down to being like, okay, this is a 6 and this is a 7, but really the amount of energy is huge. So scientists and mathematicians like log because it takes things that grow too fast and kind of shrinks them down to a manageable level. So anyway, back to this. So what we do is we find our domain, what x values can I plug in, and then we're going to plug some in. You really only need 2, and you want to make sure they're pretty well spaced apart. You'll probably end up having to do the change of base and all that good stuff most of the time. Sometimes you get lucky and you pick a good value of x. It's one of those logs you could probably just solve by looking at it, but for the most part, you probably end up using a calculator. After that, you should be ready to sketch the graph. Now, logarithms always pretty much look like one of these possibilities here. So first of all, they have a vertical asymptote. So they look really flat as they're up against that asymptote, and then they increase as they go to the right. Okay? Now, if it looks like that, then of course because of transformations and reflections, like you could have one going this way, right? You could also have them going downwards or like this. So you might want to sketch those 4 options on your paper because once we have our asymptote and 2 points, basically we're going to need to connect all that stuff together with a picture, and it's going to look like one of those 4 things there. Something I forgot to put in here was that domain, when you find your domain on the first step, you guys, that tells you where your asymptote is. So let's add a little note here. So you guys know how, like we said before, a domain is what are your possible values of x? Well, as you guys can see from this little graph that I drew for you, that's kind of like an invisible boundary line that your graph cannot cross. So the domain for this function then right here, the one that I'm tracing, is anything on the right side. So there's no graph on this side, right? So when you find your domain, that's basically telling you where your invisible boundary line is at. In other words, it's a vertical asymptote, and that's going to be the first thing we'll end up sketching. So quick review, find your domain, gives you an asymptote. Plug in some points, connect the dots with one of those pictures there, and that's it. That's all we're doing today. Pretty simple. We'll probably finish early, but we'll see how things turn out. All right. Let's see. So okay. So let's go ahead and do the first thing. The first step that I gave you guys was to find the domain. Okay, so let's do that first. The domain also tells you the asymptote, so I'll label this step in 2 ways. Okay, so how do you find the domain? You take your argument, make it greater than 0, and then solve for x, right? Don't forget that if you ever end up dividing by a negative number, you have to flip that inequality sign around. So that means x has to be greater than 3. It can't equal 3, it can't be less 3. You can only pick numbers for x that are greater than 3. So that moves us on to step 2. We only pick x values that are greater than 3. So here we go. For step 2, let's get a table of values. So you're allowed to plug in whatever you want for x so long as it is greater than 3. And we just need 2 dots. So give me a number for greater than 3. 4 is good. Now the next one, remember I said you want to space them out a little bit? More. 8? Sure, you could do 8. 10, something. The more space you get, the more increase you'll see, and so you can get a better curve out of it. But definitely want to space them out a little bit. So let's go ahead and say like 8 is fine. All right. So now here's where a whole lot of calculation comes into play. We have to actually plug that in up here and figure out the answer. So here we go. So we have, what was the log, guys? Help me out. It was what? -5, log base 3, and it was 2x, right? and we're plugging in 4 and 8, right? We're going to do 4 first. So it was 2x plus or minus, what was it? Thank you. Okay, so we just need to simplify this, okay? And we did this a little while back. You're going to take care of the parentheses first. So let's do that. 8 take away 6 is 2. And then we're going to take care of this, the log. For that, you need your change of base, right? So that's going to be log 2 over log 3. That's the change of base. It's been a little while, but the change of base formula is something where we had this before. If you have a log with a non-friendly base that you can't do mentally, you can change it to base 10 using this formula here, so you can use a calculator to get the answer. So it's called the change of base formula. We talked about it a couple lessons ago. All right, so from here I'm going to get out my calculator and let my calculator do most of the work for me now. So I'm going to do log of 2 divided by log of 3. That didn't go the way I wanted. That's interesting. It's a new creation. I didn't know it did that. All right. So we have -5, and on my calculator I'm getting 0.631. I like to round to the thousandths place when I do this. Let's multiply that by -5. So that's the next part, is to do your multiplication, right? PEMDAS. And then subtract 1 from that. .155, and that's y. So what number did I plug in? 4. And what number did I get out? Yeah, -4.1. And at this point for graphing, I would say go ahead and just take it to the tenths place at most, because when it comes to graphing, you can't get that precise anyway. So there you go. That's one of our points that I'm going to plot. All right? Okay, let's do another one. What else was I going to plug in? 8s. Why don't you guys try that one? I'll pause for a second and let you guys work on that. See if you can find out log of 8. If you need a calculator, go ahead and come grab one. So when I plug in 8, we end up with something like 11.5, so 11.5. So coming back up here to my table of values here, we got 4.2, or -4.2, right? And then it was -11.5, right? Okay, good. So those are the 2 points I'm going to plot. So now we're actually ready to graph, okay? So let's review real quick what we did before we go any further. So step 1, find your domain, right? That tells you what x values you're allowed to pick. Make sure your x values are spaced out good. Plug them into your log and solve. Once you've got that, you're ready to start graphing. So let's do it. It's the last thing we're going to do. So the first thing we're going to do is we're going to graph that asymptote. So what was the domain? X had to be greater than 3, right? So here's what we're going to do. We're going to go over 3 on the x-axis. We're going to put an imaginary boundary line there to represent that domain, or that vertical asymptote. Because we know that x has to be greater than 3, right? So that's our imaginary boundary line we're not allowed to cross. Now, I'm going to plot the 2 points that I got, right? So you guys told me to plug in 4 first. And when we plugged in 4, we got 4.2. So I'm going to go down to 4 and just put a dot kind of there-ish. And then we went over to 8 after that. We plugged in 8. So 4, 5, 6, 7, 8. And when we plugged in 8, we got negative 11. So I got to go a little bit further down here. 6, 7, 8, 9, 10, 11. So by the time I get over here to 8, we're down here at 11-ish, right? Okay, now remember the pictures I told you to graph? Which one of these shapes would connect the dots and hit the asymptote in the right way? A, B, C, or D? D would. And so we're going to draw a picture that looks like that. So it's got to hug up against the asymptote and then hit those 2 dots. So there you have it. That's graphing logs. I know it seems long, but it won't take you guys that long once you get used to it. There's your graph. Okay? That's what that function would look like. All right? Guided practice problem here. I'm going to throw it at you real quick. And then we'll throw one more student practice at you and we'll call it a day. So let's say we have the following. I don't want to come up with decimal answers. It's kind of irritating when that happens. Okay, so I'm going to ask you guys to walk me through this a little bit. So let's start off with Ashley. Ashley, what's the first thing I need to do? Find the domain. Good. So go ahead and do that, guys. I'll give you about a minute. So we would have started off like this, you guys, right? And then when you solve, you're going to get 2 as an answer. But since we divide by that -6, that inequality switches around. So what this means is that x has to be less than 2. All right? So the next thing is going to go to Kondaker. So Kondaker, what do I do now? Plug in some x values into a table. Good. So we're going to do a table. And Giovanni Ramirez, what x would you like me to plug in?
1.
1. Good. He picked a good number because it has to be less than 2. All right. And then I'm going to ask Gio Perez, what's another number we could plug in? -2. We could do that. Now those aren't real far apart. There's only 3 spaces far apart. I might go a little further, but it could work. It could work. So we'll do it and see what happens. All right. So let's go ahead and have you guys do the next step. So you're actually going to plug them in and get your y values. So go ahead and do that. I'll wait for you guys for a little bit. Let's begin here. So Braden, what did you get for x equals 1?
I got 2.11.
Cool. And I'll just put 2.1. Depending on how you round, you know, these are funny functions. You'll be close, but Amanda, what did you get for -2? Yeah, basically 3. It was like 2.9, right? So she's just going to round up to 3, which is fine. All right, then we're ready to graph. So at this point, you want to graph your asymptote. All right. So why don't you guys see if you can graph it? I'll give you about a minute here, see if you guys can graph it. and then so we should have had a vertical asymptote at 2. We plotted our point, we plugged in 1 and we got 2.1, right? So we would have had a dot here. And then when we plugged in -2, we got 3. And then we look at our chart that I gave you guys on the last slide, how to connect those dots, and it would look something like that. And so there's your log function for that. Okay. One more that I'll throw at you guys as a student practice here involves natural log. Now, the only difference for natural log you guys, is going to be that you actually don't need to do the change of base formula, right? Because when you get to that place after you plug in a number, there's already an LN button on your calculator, so we don't need to change the base. You can just push LN and whatever number's there. So you guys know what I mean? Like, for instance, let me just give you a heads up before I set you loose on this. Suppose you decided, okay, I'm going to plug in 5, right? Let's say you plug in 5. Well, usually at this point we would do a change of base, right? But you don't have to, because LN is right on our calculator. All you have to do is push LN of 4 and you've got it. So LN's actually a little bit easier. Yeah? Oh, you're right. I picked a bad number. Thank you, Melanie. I owe you a point. I picked a bad, I said 5, which would give me -4, which is outside the domain, which means since I didn't do my domain first, I picked a bad number to plug in. But anyway, hopefully you guys got the idea there. With LN, you do not need to do a change of base. You can just do LN right on your calculator and save yourself a little time. All right, so go ahead and see if you guys can get that graph, and we'll go from there. So as far as this goes, we already talked about the domain. You could have picked any X values you want, you know, so not everybody's going to have the same answer over here. I don't know what you guys chose, but you plug it in and then you solve. But ultimately, we should all be getting a similar shape. Our shape should look something like that. Okay, so that's what we're looking for. All right, so that'll close us out for the day.